saying if we're at this point 1,24 there, 1,24, if we move a unit, okay, from 1 to the positive side, so I'm moving from 1 to 2, and because of this change from 1 to 2, y has changed from 24 to 54. Okay, so now I will try to find the slope. Okay, I will try to find the change in y per unit change in x. Okay, so how do we find that? We differentiate a given function. We just find the derivative of that particular function. So in this case, if I have this function, y is equal to 6x squared. To find the slope of this particular function, I will just differentiate this particular function. Okay, so what I'm trying to say is that differentiation is used to find the slope of a given function. So differentiation is used to find the slope of a given function. So now, how do we differentiate a given function? So for example, if we have this function y is equal to 6x squared, to find the slope of this function, I will just multiply 2 by 6, then I will reduce 2 by 1. Okay, I will multiply 2 by 6, then I will reduce 2 by 1. What do I mean by that? What I mean is this. As we wait for that to load, we can get back to our document. So if I have this function y is equal to 6x squared, to differentiate I'll just say 2 times 6, 12. Okay, then x, I'll write my x, then I'll reduce the power by 1. 2 by 1, sorry, 2 less 1 is 1, which means what I have is this 2 times 6x to the power 2 less 1, which is 12x, which means I have found, I've managed to find the slope of this particular function. Okay, which means okay, good. I've managed to find the slope of this particular function. Okay, so that is how we find the slope of a given function. We just multiply the exponent by the base, then you keep the variable, and then you reduce the exponent by 1. Okay, you reduce the exponent by okay, sorry, I don't know who this person is. I thought you wanted math. Sorry, this is math, but the topic we're looking at is very important. Okay, so that is how we find the derivative. So now let's get back to our Jamboard. So what we have is y, a function y is defined to be equal to 6x squared. 6x squared. To find the derivative of this, I'll just say dy dx. Dy dx means change in y per unit change in x is equal to, so this is just something like a x raised to the power n. How do I differentiate such a function? I will just say a times n, okay, everything, sorry, this is an open parenthesis, everything by x, but this x I'll say n minus 1. So this is how we differentiate. This is the simplest method of differentiation, which means here I'll just say 2 because 2 is my n, 6 is my a, x is that x. So to find the change in y per unit change in x, I'll just say 2, okay, sorry, this is 2 times 6x, but this x I'll reduce the power by 1. So 2 minus so let's pop in. No, it's not writing. Are you able to see this, guys? Hello, are you able to see?
Yes, but
No,
Yes.
yes,
not the what?
yes.
Oh,
It's blank.
yeah, it's blank. I don't know as well. It's misbehaving. It doesn't want us to learn. Okay, but I think as we wait for this thing to get back to normal, what we are saying is that for me to find the change in y per unit change in x, I'll just multiply 2 in this case, which was our n there, times a, which is 6 in this case. Then I'll keep my x, then you reduce the power by 1. So what I mean is this: I'll have 2 6x raised to the power 2 less 1, which is just 12x, which means the slope of this particular function, is 12. Okay, is 12. So the change in y per unit change in x is the dy dx, which is just 12x. Okay, so what are we saying? We can see that this is basically approximately correct by looking at a graph of this particular function. So in this figure, we're using this figure, any term in x squared will rise at an ever increasing rate as x is increasing. So in other words, the slope of this particular function must increase as x is increasing. So what we mean is that if I put any value of x there, the slope of this particular function will keep on increasing. Okay, so of course the value by which it will be increasing is 12. So if I have x as 1, then the slope is going to increase by 12 units. If I increase this by 2, which means the slope, as we can see, will keep on increasing to infinity. Okay, the slope will keep on increasing to infinity, but it will be increasing at a positive rate. That is why we have something going like that. Okay, so that's what the slope tells us. The slope is telling us that if I change x by 1 unit, what will be the response in y? So as we can see here, if I have this function, if I find the derivative is telling me that if I change x by 1 unit, y is going to increase by this factor, by that factor. So that's what the slope tells us. So for example, when x is 4, then the slope will be 48. Okay, when x is 5, then the slope will be 60. So that's what the dy dx tells us. Okay, so for example, if we have this equation, y is 4x raised to the power 2, which is just a quadratic simple equation. Okay, the question is, what is the slope when x is 8? So this is how questions come. They will not tell you to differentiate. No, they will just ask you to find the slope. But we know mathematically that the slope is just the change in y per unit change in x. Okay, so which means I'll first have to differentiate this function, of course, with respect to x. Then I'll fit in, or I'll plug in 8, okay, to that derivative for me to find the answer. So now, how do we find the change in y per unit change in x? I know that I'll just say 2 by 4, it is 8. Then x is raised to the power now 2 less 1. Why? Because initially it was raised to the power 2. If I reduce 2 by 1, I'll get a 1. But do not anything raised to the power 1, it is that very thing. So in this case, it will be 2 times 4x, then 2 less 1, which is 8x. But the question is, what is the slope? Okay, what is the slope of this function when x is 8? What is the slope of this function when x is 8? So now, after finding the function or the equation for the slope, where there's x, I will now put 8. And we know mathematically, even from grade 7, that 8 times 8 is 64, which means the final answer that they are looking for is not 8x. The final answer is 64, because the question is, what is the slope of this particular function when x is 8? So now, after finding the equation of the slope where there is x, I'll just put the value. In this case, is 8. So 8 by 8 is 64. So that is how we find the derivatives. Of course, simple equations. Okay, that is how we find the derivatives of simple equations or of linear equations to make things simple. Simple equations like this one, you can use that particular rule. It's going to apply. Okay, it's going to apply. Then the other question is, the other exam, is what is the slope? So whenever they're asking about slope, they are asking us what is the change in y if x changes by 1 unit. Get me right? That is what the slope is all about. Is the change in y per unit change in x, or the average change in y per unit change in x. That is what the slope is all about. Okay, so that is what the slope is all about. So in this case, we have a different function raised to the power 4, of course. So we've got the 45x raised to the power 4. So what is the slope of this particular function if x is 10? So we do the same. We just do the same. So we're going to multiply 4 times the 45. Okay, it's 180. Okay, so 4 times the 45 is 180. Then x here is raised to the power 4. But if we reduce this by 1, it will be 3. So that is why it is 180x cubed. But the question is, what is the slope of this function when x is 10? So which means now, I'll just put 10 wherever there is x, and then I'll raise that to the power 3. Okay, so that is the way we're saying when x is 10, the slope will be 180 open 10 close to the power 3. But we know that 10 raised to the power 3 is just 1,000. And 1,000 times 180 is just 180,000. So now, the slope of this particular function when x is 10 is just 180,000. But we should understand that to find the slope, what we need is dy dx. Why? We are saying the change in y per unit change in x, which we know that it is just ax to the power n, which is n times ax. We keep x, then we reduce n by 1. That is how we find the slope. Okay, but of course, we have to pay attention to what the question is asking. The question in this case is asking us to find the value of this particular function. So the slope of this particular function when x is 10, which means after finding the derivative of this particular function, whenever there's x, I'll just put 10. Okay, whenever there's x, I'll put 10 and raise that to the third power. And the 10 raised to the third power is just 1,000. So 1,000 times 180 is 180,000. So that is how we find the slope of any given function. That is how we find the slope of any given function. Now, let me just do this. Where is that? Sorry, not this. I'm so sorry. Where is that again? Please. Oh my God. Okay, it's here. Sorry. So last time, I want us to apply. Okay, I want us to apply what we've looked at so far. Last time we were looking at sorry, it's not macro. I'm just trying to help us apply what we've learned so far. Last time we were looking at finding the marginal product of labor and the marginal product of capital. So we said that given a function, so let's assume that this function is that very function 6x raised to the power 2. Okay, so given a function which is the technology which is a capital alpha less L, which is labor 1 less alpha, to find the marginal product of labor. The marginal product of labor in this case is the slope of this particular function with respect to labor. That's what it means. So, which is just the dy dx. But in this case, we're saying the derivative of this function. This means derivative, which is the change in the function per unit change in labor. So, there, we said that here we had the 2. Okay, this is more like a, then this whole thing is, it can be a, this is x, then this is n, then again we have got x to some power. Okay, so in this case, we are differentiating this function with respect to labor. So which means we're going to keep a and k constant. Okay, we're going to keep a, and K constant. So we want to find the marginal product of labor. So what we're going to do is this. We are going to keep these two constant. Then we're going to say it will be 1 less alpha, which is this. We bring down the power. Okay, let me just say that. We bring down the power. So we've brought down the power here. Times this AK alpha is constant. So we keep it the way it is. AK alpha constant. Then we then reduce this power by 1. So 1 minus alpha minus 1. It will just be negative alpha. Okay? 1 minus alpha minus 1. It will just be negative alpha. In case you're wondering why. 1 minus alpha minus 1. Here we're going to have a positive 1. Here we're going to have a negative 1. Those ones will go positive plus negative. The answer is 0. Which means we're only remaining with negative alpha. So that is why we have 1 less alpha times AK alpha. Then L raised to the power 1, raised to the power negative alpha. Because we have reduced that power by 1. So this is the application of derivatives, or the application of slopes, or the application of differentiation. Okay, so this is how we apply. Okay, this is how we apply. Okay, so that is the application. But of course, this is a discussion, so I will need some feedback from us. Are we understanding what we're talking about? Offred, Piri. Okay. Any question? Because now we are graduating to the rules of differentiation. Okay. So if you don't understand that introduction, you are not going to get anything from the rules of differentiation. Okay. So please, I don't want to go ahead if one of us is remaining behind. We don't want to leave anybody behind. Feel free to ask.
Repeat, sir.
Okay, I love that. Being open is the best thing. So, what I'm saying is, oh, wait. I should repeat where? Application or here, Mary?
Application.
Thank you. Application is here. So we have a capital alpha, then labor raised to the power 1 less alpha. We are trying to find the marginal product, of course, of this function with respect to labor. How do we do that? We reduce. Before reducing, we multiply the power of that particular variable that we are differentiating this function with respect to that particular variable. So we reduce. So we multiply, the exponent. In this case, the exponent is 1 less alpha. So we are going to multiply this function, of course. So we're going to say 1 less alpha multiplying by AK alpha. This AK alpha is constant because this is what we call partial derivatives. We are finding the derivative of this function partially, of course, with respect to labor. So we are going to keep technology and capital constant. But then we should reduce the power of this guy by 1. So 1 minus alpha minus 1 is just negative alpha. Okay, so that is how we find the derivative of this particular function with respect to labor. So we are saying we should use the laws of the derivatives. Okay, and this is just the simplest of all the equations we can find under calculus. The differentiation. The simplest is the Cobb-Douglas. Simplest is Cobb-Douglas, because as we progress, we're going to start looking at what we call the Leontief production function, which is a bit complicated because we will be asked to find the minimum point of a function. Okay, so let us understand how to deal with the Cobb-Douglas. So today I just want to do the application. So whatever rule that we're going to apply, so what we're going to look at, I'll try to find the equation that is looking at the application. So that is how we go about the simple equations. So let's try to test ourselves. So we're saying derive an expression for the slope of the function y is equal to 12x raised to the third power. So 12x raised to the third power is nothing but cannot display. Please enable. I don't know how to do that. Okay, it's okay. Technology is not on our side, but it's okay. So I'm saying, let's find the slope of this particular function, or let's find an expression for this particular function. So when a question is asking you to find an expression, what they're telling you is just find the dy dx. Okay, because that will be the expression of the slope. So dy dx will be 36x raised to the power 2. Because 12 raised to the power 3, sorry, 12 times 3 is 36. So what I'll do is I'll just multiply 3 times 12, 36, then x, then if I reduce 3 by 1, I'll get a 2, which means my final answer is 36x squared. Okay, that will be my answer. That will be 36x squared. Then the second one is saying, what is the slope of the function when x is 2? So same principle. What I will do is dy dx is 4 times 6, 24, x raised to the power 3. Why? Because I will reduce 4 by 1, which is 3. So I will have 24x raised to the power 3. Then, after doing that, wherever there is x, I'll put 2. Okay? But we should take note that that 2 is raised to the power 3. So, since my equation is 24x raised to the power 3, what I will do is simple. I'll just say 24, 2 raised to the power 3. Okay, raise the power 3 and find my answer. So if you do 2 raised to the power 3 is just 8. So I'll have 8 times 24, which means your final answer is the product of 8 and 24, which is 192. So that is the value of this slope when x is 2. Okay, we are done. Because this and that is the same thing. Then the fifth one is just, asking us to apply, which just say let's make our own single term function and then differentiate it. So you can come up with any function, a billion x raised to the power 7, find the derivative. You just multiply 7 times a billion, you keep the x, then you reduce 7 by 1. Okay, which will be billion times x raised to the power 6. That will be your answer. I'm just giving an example. So that is how we go about finding derivatives. Okay, that is how we go about finding derivatives. This is a discussion, so let's go. Do we have questions? Let's throw in the questions.
Come again, please.
Yes, Sandra. I believe it's Sandra. I should come again where?
Yes, on the fifth question.
The fifth question is just saying make up your own single term function and then differentiate
That
it.
question.
So
The fourth, I mean.
Oh, sorry. The fourth question, derive an expression for the slope of this particular function. So this function is equal to that function. This question is equal to that question. No difference at all. All they are saying is we should come up with an expression for the slope of this particular function. So what you do is dy dx will be 52 times the 3x raised to the power 2. So just multiply 52 times 3. You find the answer. Then x raised to the power 2. Y to the power 2. This whole function. Okay, thank you. So this function is raised to the power 3. Okay, this function is raised to the power 3. So if I reduce that by 1, I'll have a 2. Which means my final answer must be 3 times 52, which is 156, x to the power 2. So my answer is 156x to the power 2. So that is how we do that question, Sandra. Any other question? Another question? Another question? It's quiet, I believe Ali as well. Okay, let's look at the first one. Okay, under the rules of differentiation, which is what we've been looking at anyway. It's part of the rules. The simple way of doing calculus. Okay, so if y is equal to ax raised to the power n, where a and n are the given parameters, then the dy dx will be n, which is the power, times a, which is the base, times x, which is the variable here, and then we reduce n by 1, which is what we've been doing. So let's apply that. We're saying let's differentiate this particular function. So now, this is a cubic function, because the highest power here, also not even cubic, it's raised to the power 4. Okay, it's raised to the power 4. So we do the same thing. So this is what we call combined differentiation, because we have got that expression, that expression, that expression. So it's combined. So this is what we call combined differentiation. So how do we solve the combined differentiations? We know that I'll just solve this in parts. So I'll solve this one, I'll solve that one, and solve that one, and combine them. That is why it's called combined. So I know that if I differentiate this, I'll have 6x as 6x as my final answer. Okay, if I do this, I will have 30x squared. If I do this, I have 0.80x to the power 3. But how? So this is 3x squared. How do I do that? I'll just multiply 2 by 3, which is 6. Then x, 2 less 1 is 1. Anything raised to the power 1 is that the very thing. So I have 6x here, just here. I'll have 6x. That is that 6x. Okay, and then I come to this. 3 by 10 is 30. X, then 2 less 1 is 2, which means I'll have 30x to the power 2. Then 4 times 0.2 is just 0.8. Okay, 4 times 0.2 is just 0.8. Then x is raised to the power 4, but when I reduce that by 1, I will have to the power 3. So that is that expression that is there. So this is how we find the derivatives of combined equations. Oh, sorry, combined expressions. So whenever you encounter such a question, just go and hammer it step by step. You do the first one, the second one, and the last one, just like that. So these can be anything they can give us. Let's say 4x to the power 100 plus anything. What you do is just use this. Just use this thing here where my cursor is. Okay. Application. Find the slope of this particular function when x is 10. Find the slope of this particular function when x is 10. So, how do I find the slope of this particular function? We know that I'm just going to use the first rule of differentiation. So, if I find the derivative of that is 12x, no doubt about it. It's just 2 by 6, which is 12x. Then I'll reduce 2 by 1, which is just 12x. Minus 0.5 by 3 is 1.5. Okay, 3 by 0.5 is 1.5, because what you can do is you're just more like saying 3 times 5, which is 15. But I've got to, this thing is to the first decimal point. So you just bring the decimal point there. You know how to multiply decimals. Okay, then x to the power 3, when I differentiate that, it will just be to the power 2. But the question is, what is the value of this? What is the slope? What is the value of the slope when x is 10? So I'll just plug in wherever there's x, I'll put 10. And then you find your answer, which is negative 30, which means the slope of this thing when x is 10 is downward sloping, because I've got a negative slope. Okay, so the value is negative 30 at that particular point. Okay, so this is how we play around. This is how we play around. The last one, which is the last one, we can't keep on doing the same thing. The last one is this: derive an expression for the slope of the function this for any value of x. So here, whenever they're asking you to derive an expression or for the slope, just differentiate the function. Just find the derivative of that particular function. Off you go. Okay, so I know that if I differentiate this, I'll get 8x plus, this is 6x squared. This is less 4x to the power 3. Then 0.5 times 0.1 is just 0.1 times 5 is just 0.5. Then x raised to the power 4, which is that thing there. So if the question was find the value of this particular function when x is 100. After differentiating, wherever there is x, I'll just plug 100. Wherever there is x, I'll just plug 100 and solve. And solve. So let's apply that to here. Sorry, we're trying to kill two birds with one stone. So the question is saying I want the one with differentiation. So let's say we are finding the marginal product of capital. Okay, let's say we are finding the marginal product of capital. Of course, the questions are a bit different. Okay, so let's say we are finding the marginal product of capital. Let's get back to our initial equation, which is here. So if we're finding the marginal product of capital, I'll just differentiate this function with respect to capital. That is what I'm saying. I'm saying the derivative of this particular function with respect to capital will be, so now capital, the exponent for capital is that, which means in this case I'll keep labor constant. Okay, I'll keep labor constant because I'm finding what we call the partial derivative. We're using partial derivatives. So I'll keep labor constant because I'm differentiating this not with respect to labor but with respect to capital. So what I'll do is this. I will say the exponent of capital times this thing. So it is the exponent of capital is alpha. So I'll say alpha times capital, then alpha minus 1. Okay, alpha minus 1, then labor 1 minus alpha. I'll keep this as it is there because I'm finding the derivative of this function with respect to capital. So labor in this case is kept constant. Okay, then you just multiply. Okay, you open the brackets, multiply, off you go. So that is how we find the marginal product of capital using the first rule. We're using the first rule here. So that is how I was finding these values or these expressions. Okay, good. Good. So no, we cannot look at that because it's simple, because it's just 8. The answer is 8. So Elman's mic is on.
Please show the first row.
The first what? Kukenga.
The first row, please show it.
The first one. I don't know what you mean by the first one. Is it this or the application of the Cobb-Douglas?
Please show the first row.
Oh, the first row is this. The first row is this. Kukenga. I've showed it.
Alright, thank you.
Perfect. No, I wanted to explain something here. So don't get confused. We know that anything raised to the power 0 is 1. So this one will just be 8. The answer will be 8. Why 8? We know that there is a 1 here. Okay, there's a 1 which is not shown, but we know that there's a 1. So 1 times 8 is 8. X raised to the power 1 minus 1 to be 0. But x raised to the power 0 is 1. So 1 times 8 is 8. So this is where the 8 is coming from. Okay, this is where the 8 is coming from. So which one should be our take home? No, this one has got an answer already. So you've seen the answer. Okay, so but we use the same thing, use the same rule, no doubt about it. Use the same rule. Same thing here. This will just be 14. Okay, we are tired with using the first rule. It's the same thing. What is the slope of the function? Y is equal to 4x to the power 0.5 when x is 4. So you just multiply 4 times 0.5. Okay, then which will just be 2 because 0.5 is half. So 4 times half is 2 because half of 4 is 2. So half times 4 is 2. So it will be 2 times x. Then this will become negative half because 0.5 is half, and half minus 1 is negative half, and negative half is 0.5, which means we have 2x raised to the power negative 0.5. But they are saying when x is 4, so you put there. When you put 4 there, you find that when you solve, the answer will be 1. When you solve, the answer is 1. But now the Kajam board is misbehaving. I wanted us to look at how to play around with inverses. Now the technology is misbehaving. It's not my fault. We can't display. Please enable. I'll look at this maybe as we prepare for the second session. Sorry for that. It's not my fault. Okay, so just to show you, get a pen and a paper wherever you are. So we have y is 4x raised to the power 0.5. So I'm saying a change in y, a change in x will just be 4 times 0.5, then x raised to the power negative 0.5. Why negative 0.5? Is because 0.5 less 1. Because we're saying half less 1. Okay? So if we remove 1 from half, we're going to have a negative half, isn't it? So this will just be 2x raised to the power negative 0.5. Okay? So now we know that x raised to the power negative 0.5 is just more like we are saying what is the inverse of x raised to the power positive 0.5. Get me right. X raised to the power negative 0.5 is more like we are finding the inverse of this particular variable. So this thing 2 someone's mic is on.
Yes, is it example 8?
Is it example what? It's this example 8.12.
8.12 or the one you want to.
No, this same one. I want us to understand something here. 8.12. There's something tricky which I want us to understand.
Okay.
Thank you. So let me restart in case some need to know which one I was solving. So I'm saying this one 8.12. So the question is, let's find the slope of this function. Y is equal to, please get a pen and a paper, write what I'm talking about, because the Jamboard is misbehaving today. So I've got 4x raised to the power 0.5. I believe you have written that. So the change in y, okay, which is just dy dx, will be 4 open brackets 0.5 close open brackets, okay, x close raised to the power negative 0.5. Okay, so 4 times 0.5 is just half of 4, and half of 4 is 2, so it will be 2 times, or you can just say 2x to the power negative 0.5. Okay, but what I was saying is this thing x raised to the power negative 0.5 is the same as 1 over x raised to the power 0.5. Okay, why? The answer is, you remember the laws of indices. Okay, the laws of indices. Actually, calculus and the indices, these guys are inseparable. You can't separate the two. So if you didn't understand the indices, sorry, go back and check your work. So x raised to the power negative 0.5 is just more like the inverse of x raised to the power 0.5. And the inverse of that is 1 over x raised to the power 0.5. Meaning that I can rewrite 2x raised to the power negative 0.5 to something like 2 over x raised to the power 0.5. It's the same thing. Same thing. Okay? Or you can say 2 open brackets, the big parenthesis, 1 over x raised to the power 0.5. You close. It's the same thing. Same stuff. Okay? Now, to prove what I'm talking about, let's say we have 2 over x raised to the power 0.5. So the question is saying, let us find the slope of this particular function when x is 4. Okay? When x is 4. Again, we know that any variable raised to the power 0.5 is equal to any variable raised to the power half. Okay? We're just playing around with indices here. These are the very basics that we have to understand for us to go deep into calculus. So, we know that x raised to the power 0.5 is the same thing as x raised to the power half. Again, we know that anything raised to the power half is more like the square root of that thing. I don't know if we are together. Okay? The whole thing has started from the inverse of x. So, x raised to the power negative 0.5 is the same thing as 1 over x raised to the power 0.5. And then I can rewrite 2x raised to the power 0.5 to be something like 2 over. Ati? Is it my net? I can't get you. You're breaking. Who's on the floor? Feel free. Let's ask. Let's move together. Okay. It's quiet. I believe Ali is well. Where's Christopher? Christopher, are you there? Christopher, can you get me? The guy.
Sir, we are allowed to use calculators?
Very much. You are allowed. This is mathematics. You are allowed.
Then it's easier using a calculator.
No, it's not easier to use a calculator. It's easier if we use our own calculators. Because if we use our own calculators, we understand what we're talking about. Okay? So that's the difference. Don't rely on...
Sir, repeat your
Same.
Yes, Mary.
Repeat on the question you are solving.
The question we are solving is 8.1 2.
Yeah, now repeat.
Oh, it's if y is equal to 4x raised to the power 0.5.
Yes,
Uh,
repeat your explanation in short.
all right. So divide the x will be 4 times that 4. So 4, this 4 times 0.5 is just half of 4. Half of 4 is 2. I'm here. Here. Where my guesser is? Here. So that is how they found it, these 2 times. Okay, so times the x, we'll keep the x. Then 0.5 less 1 is just negative of 0.5. But what I'm saying is x raised to the power negative 0.5 is just more like we are looking for the inverse of x raised to the power 0.5. Are you there?
Yes,
Yes. No. We don't use mathematical sets, Sandra. We don't use those. We don't. They are not needed anyway. Because we are not doing geometry. Okay, we are not doing geometry in this course. We only use those if we could have been using those if we had anything connected to geometry. Yes, Mary was on the floor. Oh, okay. Let me continue. So what I was saying is this thing starting from here going that side, x raised to the power negative of 0.5 is the same thing as 1 over x raised to the power 0.5. Okay, it's the same thing. So anything raised to the power negative is the inverse of that raised to that particular power. Okay, so we have 2 times 4 raised to the power negative 0.5. Okay, no, let me not confuse you. I'm here. So 2x raised to the power negative 0.5 is the same thing as 2 open brackets 1 over x raised to the power 0.5 close. Okay, so write that this is equal to 2 over, okay, x raised to the power 0.5. So the question is saying what is the value of that slope when x is 4? So what we'll do is we'll get say 2 over our x is 4. So I will say 4 raised to the power 0.5. Okay, but 0.5 is half. Okay, 0.5 is half. So this can be 2 over 4 raised to the power half. But anything raised to the power half is more like the square root of that thing. Okay, so this will be 2 over the square root of 4. What is the square root of 4? Is 2. What is 2 into 2? 1. So this is how this is how they found this one. So what I want, guys, is that yes, we use calculators, but some of these things you need to know what you are doing. It's not just about punching and everything. Punching is simple, but try to understand so that even as you are punching, you know what you are doing. Because again, if you don't know what you are doing, it's very much possible that you may punch something that is wrong. Okay. Yes. So that is that. So this is how the one was found. So please, anything raised to the power negative is just the inverse of that. Okay, and anything raised to the power half is just the square root of that. Anything raised to the power 1 over 3 is the cube root of that. Anything raised to the power 1 over 4 is the fourth root of that. That is how we play around with mathematics. So know those two simple stuffs. Know them. They are very helpful. We can't do this. It's simple. So I'll pick this 3. So please, each one of us, please get a paper and a pen. Today I'm in a very good mood. Slow motion. I just want us to understand these things. I don't want us to start crying at the end of the day. So get a pen and a paper. Let's solve this. Okay, let's solve that. But I won't tell you my answer because I want you first to solve on your own. So this is just under a minute. So this is 1951. By 1952 should be done. So the question is y is equal to 4 plus 4x raised to the power negative 1 minus 4x. That is the question I want each one of us to solve. Okay. So I believe we've all copied the question, and I believe we've all started solving. So under a minute we should be done, because this is very simple. Because I'm done already. I'm done.
Done.
Okay, so who is saying done? I have to know that person. Who is done? Sandra, you're done. Tell me your answer.
It's in negative 4x to the power negative 2 minus 4.
Minus 4 what? Minus 4, isn't it? Correct. You're correct. That answer is very much correct. So in case you're wondering what Sandra has done, what she has done is she has just multiplied the negative times 4 to give a negative 4. Then x kept, we're going to keep it constant. Then negative 1 minus 1 is negative 2. So that is how she came up with the negative 4x raised to the power negative 2. Then minus 4, we know that this, when we differentiate this, will just be 4. So the answer is negative 4x to the power negative 2 minus 4. So that is how we find the formula for the slope of the function. So if this kind of thing has come in your test, just hammer it. These are things that even when you see the paper, you start blessing the tutor and the lecturer for preparing such a simple thing. Okay, the last one. Let's see. Now a boy should do. Sorry, not a boy, but a gentleman. Yeah, a gentleman must give us an answer. Let's do this one. The last one. This one. The question is y is equal to 25. Let's see. 0.1x raised to the power negative 2 plus 2x to the power 0.3. That is the question that we are solving. Okay, I'm done. I found my answer already. So let's. I'm waiting for a gentleman to give us the answer. Gentleman. No, let me get back to the question in case there's someone wants to see the question. Okay, under a minute. This is 54 by 55. We should be done. Gentlemen. Christopher, what's your answer? Does it mean that the gentleman is not here today? How? Okay. Chikerete, what's your answer? You.
Is
y
is equals to
dy dx is equal to continue now.
0.2x raised to the power negative 3 plus 0.6x raised to the power negative 0.7.
Correct. That answer is very much correct. Okay, so you just have to wait. Did you say negative 0.2?
0.7.
No. I mean, restart your answer again.
Dy dx is equals to 0.2.
Correct. Just there. No, just there. I just wanted to get that one. Okay, because we have a negative here and a negative there. Please pay extra attention to science. Trust me. Lecturers and tutors, these guys are, I don't know, they're very strict. You miss a negative, your answer is wrong. Mathematically, your answer is wrong. Because if something is going in the negative side, you say it's going in the positive side, which means you are lying. So they will mark you wrong. Your answer is wrong. So please pay attention to science. Thank you so much, Mr. Chikeret. So that answer is correct. Now, let's now try to apply. Okay? This is mathematics for economics. So we should now be able to apply these things in economics. So let's now try to find what we call the marginal revenue and the total revenue from calculus, from differentiation. Okay? Today, we are just looking at the first principle, the first rule. I'm not rushing. I just want you guys to understand. And we still have a long way to go. I love mathematics. It's nice. Okay, so let's now start applying. So now, whenever in economics you find this thing, marginal. Just know that it's differentiation. Marginal is just the change in y per unit change in x. That is the marginal. The incremental. In first year, we are saying no, it's the incremental output, the incremental utility. But now we want to, have hands-on. We want to understand what marginal means mathematically. So marginal means incremental. So if they're saying marginal revenue, they're saying the incremental revenue. Marginal product, the incremental product. Okay. So, for example, they are saying, let's differentiate this function from the first principle. So now, I don't know if you guys looked at the first principle in first year. Okay? I don't know if you looked at the first principle in first year. But the first principle... Yes. Someone's mic was on. Feel free to ask. Oh, okay, it's quiet. I believe that is well. So the first principle is nothing.
No, it's not a question. I said we did.
Oh, you did this in first year, isn't it? Yes, thank you. Thank you for confirming that we did the first principle in first year. I love that. So first principle is nothing but the same thing that we are doing. The only difference is that we're just introducing delta. That's the only difference. We're just introducing delta. Okay? So now, they're saying let's differentiate this from the first principle. Of course, you'll never find any question in mathematics or economics asking you to use the first principle, because they know that this thing is simple. Nothing. They'll never ask you this. Trust me. The only thing they'll ask you is find the slope, because they know you know what the first principle is. Okay? So, but for the sake of revising, let's do the first principle. Okay, let's do the first principle. So the question is this: 6x plus 2x squared. Okay, let's differentiate this from the first principle. So now we are saying, let's make an assumption that x is increased by a very small amount, and this very small amount we are calling it the change in x. So this is just delta. Okay, this is a Greek letter delta, which usually signifies a change in a variable. Okay, I believe we know these things. So now we are saying we're making an assumption that x is changing, but with a very small amount. Maybe it's a point, something very minute. So you are saying this will produce a small change in y. Okay, so that change in y is represented by this delta y. Okay, so this is the original function. So the new value of y after that small change in x. Okay, so I love applying. Let's say we are saying that this y is consumption. Okay, and this x is income. Just give an example. Okay, so we want to find out what is the change in income if we change what is the change in consumption, because y is a dependent variable here. Let's say y is consumption and x is income. So the question is, what is the change in consumption if we increase income by a very small amount? Okay, that is what we're talking about here. So we are saying that the new value of y, which is y plus some change in y. Okay, so the y is the initial value of y before we increase before we encountered any changes in y. So we are saying that the new value will be the initial y plus that incremental y resulting from the increase in x. So we are saying that the new value of y can be found by substituting the new value of x into x plus change in x, which is true. Okay, because this change in y has been induced by the change in x. Okay, I don't know if you're following. We're using the first principle here, which someone has confirmed that we did this in first year. So we are saying that the y plus the change in y will be 6. Okay, will be 6. Open brackets. Whenever there is x, we're now going to put the x plus the change in x. Initial x plus this change in x. Wherever there is x, we're just going to plug that. Okay? So, what we're saying that this will be 6 open brackets x plus change in x plus 2 open brackets x plus change in x. We close the brackets, but we raise this to the second power because this x is raised to the second power. So the y plus the change in y will be 6x plus 6 change in x. We just open in the brackets here. Then we know how to open the brackets when something is raised to the second power. It will be 2x squared plus 2 squared, so which will be 2 times 2 times change in x, which is 4x change in x, plus 2 times the change in x squared. Okay? Okay? Program I started somewhere.
Asa,
Yes, please.
Asa, I'm not getting anything since you started talking about this thing.
What? Where? Where are you lost, my dear? Where are you lost?
From the time you told the gentleman to give the answer, and then afterwards, what you started explaining till now, I've not gotten anything. So,
Why?
can you repeat?
Am I not clear? Am I breaking?
You are breaking in my end. I don't know. There.
Really? Guys, am I breaking? Offred.
You're not.
To me, you are breaking. I don't know to others.
Yes, Offred, am I breaking? I just want to get a clear picture.
No, you're not. You're allowed. I think it's the network.
Okay, so then if it's the net, don't worry. The session is being recorded. Don't worry about that. Mary, don't worry, my sister. Don't worry, my dear. The session is being recorded. So, don't worry. Okay? If you're having network challenges, no worries. That is why we record these stuffs.
But I can hear now, so maybe you can just.
Okay, I'll explain that from here. I'll explain that from here. What the gentleman did was, in an instance that this was, we're assuming that this was the function. So what the gentleman did was, he just multiplied 1 times 6, which gave him 6 times, okay, times x kept constant. Then there's a 1 here. 1 minus 1 is 0, which means this will be 6. Then plus. The gentleman did 2 times 2. The 2 is the power there, the exponent times this 2, which gave him 4. Then he kept x constant. Then he reduced the power by 1. 2 less 1 is 1. So the final answer the gentleman got was 6 plus 4x. So it's the same thing that the gentleman did, which I have explained here, Miss Mbozi. Okay? Same principle, no difference whatsoever. Okay? Okay, she's quiet. I believe, I don't know.
Yeah, but then.
Thank you so much. Thank you so much. So now, we are here. We have replaced, and then we've opened the brackets, and then the final thing that we have to do now here is we have to find y. Oh, okay. We have to find. Yes, is that Sandra?
Yes, please.
Yes, Sandra.
Yeah, how does this first principle in second year differ from that one that we learned in second?
There's no difference, my sister. No difference. No difference whatsoever. It's the same thing. It's the same thing. We are just revising. Actually, we've not yet studied the calculus. Trust me. We've done nothing. We've not yet studied the calculus. Because differentiation is just a very small component of calculus. There are sweet stuffs coming. That's why mathematics is nice, huh? It's involving.
So, sir, I have a question.
Yes, sir.
So this one, the first principle that you're showing us, is the same one. Is the same one as the one that we did in first year, where we used a formula. It was a formula that we used.
Yes, it is that very formula that you are applying now here.
All right.
We're just applying that formula that we had in first year. Okay. Are you there? Yes, I believe you are.
Yes, I'm there.
Okay, good.
Yes.
So, in case you are wondering what the formula is, the guy is talking about, let me just show you something. Today we are on the cool side. Don't worry. We want us to be on the same pace at the end of the day. Ooh, this is my stuff. Where is mathematics or economics? Is Alpha Chiang. And the book I love is Alpha Chiang. It's very nice. This book. It's nice. The best book so far for mathematics. But this one is photocopy. So you can search. There are photocopies. Okay, well, I think we're just wasting time. But I believe we all know the formula the guy is talking about. It's something like f of x is equal to, I don't know, some change in x plus something minus the original function times the change in x, something like that. Look for the formula. Was the
Yeah, it's the one.
yeah, it's that very one. Okay, so let's continue. The aim is to reach here. To using the first principle, we reach here. So I was explaining this. That we just open the brackets here. When you open the brackets, we just substitute. Okay, then you divide by the change in x. So everything that has got change in x, you divide. Okay, we are applying the first principle. Don't get lost. We've replaced. After replacing, we've opened the brackets, and then we want to find y, because that is the value that we want. Okay, not we want to find the y. So we're just going to divide by changing y here, and then anything that has got change in y, we divide by that. Which means everything is going to go. This one, this 6x and that x will go. This 4x and the change in x will go, and then this guy and that guy will go. Okay, which means if I divide through by changing x, I'll have 6 plus 4x plus 2 change in x. But we've said that this change in x is very small. Very small. So we're just going to assume that this change in x is small. So it's just going to disappear. If it disappears, we are going to have 6 plus 4x as divide the x, which is the value if we differentiate this. Even without using the first principle, the answer will be 6 plus 4x. Okay, so this is how you apply the first principle. So in case you find any question asking you about application of the first principle, this is how you do it. Someone's mic is on. Yes, go ahead.
Please go back to the principle. Yes. The part where it says subtracting and gives you that, I don't understand that part.
The part I'm saying what?
Where the book is subtracting one, then gives. Like, please explain what that means.
I don't know if I'm the only one who didn't get that clear, but I think what she's asking is about how we remove one from the powers. Is that the question? Is that the question?
On your
here
slide.
Yes, this is
saying subtracting.
I'm saying subtracting.
Yes. After that.
Okay, type something. I can't get you. Your network is breaking. Just type. I'll read.
I think she's saying that what is written by the left side is subtracting one.
Where is that? Where is it saying subtracting one? People's networks are pathetic today. I can't get anything.
I think she's asking about the part where you have to subtract.
Okay, so what I'm saying is, if you follow the first principle, there is that part where you have the change in x plus the minus the initial function. But what I'm saying is, of course, if you use that formula, you still get the same answer. But here we are applying that formula. Okay, so if you use that very formula, if you follow that formula from first year, or you do this route, you still get the same answer. So because now I don't know where the subtraction part is coming in, so now I'm going to beat both sides. So if you use the formula, there is that part for subtraction where you get the original function, put it there and subtract, solve. If you use that very formula in first year, you still reach here. If you use this first principle, you will still reach here. If you use the initial method that we've used, that we've talked about, the anx to the power, x to the power n, what we do is you just say an exponent. Let's use this one with 2. 2 times 2, 4. Then you keep your x. Then you remove 1 from 2. That is general. I have no explanation for that formula because it's general. That's the way things are supposed to be done. So I don't know which subtraction. I believe that the subtraction part I've managed to answer it in one way or another.
The division part.
The division part, good. The division part comes in because we want to find the change in y per unit change in x. Okay, so we have y plus change in y, and then here we have 6 x plus the change in x. So what we want is to find the change in y per change in x. Okay, so for me to get that, I would just say, okay, the initial equation. No, let me not even go to the initial equation, to the last equation. We divide this whole function by the changes, so that at the final answer, I should have that thing down there, the change in x. So that is the main reason as to why I divide throughout by the changes in the variables. By the changes in y this side, because here I have the y variable. And then the changes in x this side, because I have the changes in x. So I divide through by the changes so that I can get this expression. This change in y to do the change in x, because that is what I want. I want to find the change in y because of having that small change in x. So that is why I'm dividing through by the changes in the variables. Okay? Okay? Okay.
Can you divide again? I'm behind. I didn't get the question how to divide it. Divide the equation.
We divide throughout so that I get this where my cursor is. For me to get the change in y due to change in x, that is what I want. That is what I want. So for me to get this expression, I will divide through by the changes. The change in y, I will divide through where there is. I will divide this side where I have my y. Then I will do the same where I have x. I will divide by the changes in x. So the whole purpose of doing that is to get this expression change in y due to change in x, because that is the whole theme of differentiation. So that is the reason why I'm dividing throughout by the changes. Okay? Okay?
Alright.
Okay. So to prove.
No.
Oh, sorry. sorry. Yes, go ahead. Who is there?
I'm still behind
Where?
on the part of dividing.
Okay, Walia. Okay, Walia, we are dividing because we want to get an expression of change in y due to the change in x. Our goal is to find the change in y because of that small change in x, isn't it? Isn't that our aim? Okay?
Yes, okay, I get that part, but like
Here.
where you've put the line, and then they say change in y is equal to change 6 change in x plus 4 x change in x. How are you canceling out that to find yourself with?
Oh, I see. Okay, so I have 6 change in x there, I have 6 change in x, isn't it? So this part will go, isn't it? Okay, this part will go. Then I have my 6x kept there. Then I'll have my 2x squared. Is it 2x squared? Yes, 2x squared kept there. And then I have my this, that, and that part will go. And then I'll have my this is 2 changing x squared, then again 2 changing x squared. Then dividing through by changing x. I'll have so what do I have? 6? Why 6? Oh, I see where the complication is coming from. Okay, so for me to explain this, let me just share this document. Just a minute. The book is still needed. Where is that book? Alpha Chian. I believe it's this. Perfect. So we're using the first principle. The first principle. Just a minute. Could it be here? Nope. Nope. Okay. Let me just search for something. Derivatives. Gosh. Okay. Okay, good. I found it. Okay, so let's go. This is the first year method for what we are talking about. So I'm saying the function of x naught is the initial. Okay, in that case is, I don't know if we're using x1 plus the change in x minus the initial function over the change in x. So for example, given the function y is equal to x squared less 4, we can write this as being f x naught is the initial function. Okay, it's the initial function. So we're going to say is equal to 3 open brackets x naught. So whenever there's x, we put x naught squared less 4, which is going back to the function. Okay, going back to the function, we are saying change in y, do a change in x. Okay, so this will be the function of x naught plus the change in x, which is, we start 3 open brackets x naught plus the change in x squared minus 4. So therefore the difference quotient, okay, which is called the difference quotient, will be, if we open the brackets, okay, if we open the brackets, and then because we're applying this thing minus the initial function divided by the change in x. So this will be change in y due change in x will be 3 open x naught plus change in x squared less blah 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 blah. This is the initial function, and then this is the change in x. So when you open that, you have this. So let's understand how this part came about. So let's open together. So I've got, if we multiply this, okay, if we multiply this will be 2 times 3. Okay, so that is where the 6x naught is coming from. Okay, 6x naught. Okay, let's open. So I've got 3 open brackets. I'm writing, be writing as well, x naught plus 4x squared minus 4 minus 3 open, 3x naught squared less 4. So if we open the brackets here, we are saying, let me keep the 3 outside. Okay, let me deal with what is the brackets first. So I'll have 2x naught plus 2 by 4 by x. Let me just finish 8x times the x naught, 3 to x naught plus 2x naught for x plus that squared. Just a minute, I'm doing something. Minus 4 minus 3 x naught squared minus 4. Everything change in x. Because let me just try if the Jamboard can be shared so that you see what I'm talking about. Let's pray hard that it does. This is now depressing. Okay, I'm coming. Let me just finish solving so that even as I'm explaining, I know what I'm talking about. So this will be 6x naught plus 6 4x plus 16x squared minus 4. 3x naught squared minus 4 over change in x. Okay, all right. Now the funny thing is you can't see what I'm like I don't know how I can do this now because I needed you to see what I'm doing. So I don't know what we can do. So let's take it by faith. But I love the practical part. If I was writing and then you're seeing what I'm doing. Oh, what can we do now? Okay, let me try to. Again, typing is another thing. Does anyone know how to solve this error? If there's anyone, please assist us. Does anyone know how to solve this error? Or is saying cannot display Jamboard, please enable WebGL. Does anyone know that? How to solve that? I want to show you something. Because I'm only remaining with 8 minutes. Please, please, please. Okay, there's no one? Okay. Let me get back to the book then, since there's no one. Okay, so when we open the brackets, okay, when you open the brackets here, and then you distribute the negative here, you are going to find that you are going to have variables that will cancel. Okay, so what we'll do is this. Maybe for the sake of me solving, I'll solve. Then what I'll solve, I'll share in the group so that we see how we arrive here. Of course, as I'll be solving, I'll be explaining as well. Okay, but before that, what you do is this. You plug in the values, which is x naught plus z change in x squared. Okay, then you open the brackets, you distribute the negative, which of course you can do this. You can keep the 3, then you deal with what is in the brackets. Okay, you deal with what is in the brackets. So you distribute the square to everything that is the brackets. Then after doing that, multiply everything by 3. Because we are keeping the 3 constant in this case, so to first deal with what is in the bracket. Then after that, when you do that, you also distribute this negative here. Then you're going to find that you are going to have values that will cancel. Okay, I will show when I solve. Then after that, you are going to remain with 6x naught times the change in x, which is coming from the 2 times the 3 is the 6. Then you multiply that by the x naught. That is where the 6x naught is coming from. But this change in x is coming in because when you distribute the 2 by everything, you know how we solve expressions raised to the power 2. We say 2 times this, you find the answer. Then you come and multiply 2 times this times that. So that is where the x naught is coming from. Then, of course, when you cancel, you're going to remain with this thing. 6x naught change in x plus 3 change in x squared over change in x. Okay? But the same assumption that we've made in that book is the same assumption that we're going to make here. That we're assuming that this change in x is very small. Okay, I don't know if they said it here, I don't know. I don't know. Okay, but we are saying that this change in x is very small. Okay, so we are saying that this function can be evaluated if we are given x naught and the change in x. So let's assume that x naught is 3. So if x naught is 3, then the change in x will be 4. But don't worry. When I send the solution, I'm going to explain how we came up with where is that question? How we came up with this 6 plus 4 in x. Okay, it's just that I can't. You have seen there's nothing I can use for you to see what I'm doing. Okay, but I will send immediate after this. I think I'll just have to take a bath and get back to my books. The moment I get back to my books, the first thing to look at will be this. I'll send the solution to how we come up with that. But of course, the conclusion that we can make is that whether you use this formula or you use what is alpha chang this formula, or you use the k1 ax n minus 1, the answer that you should get is that. Okay, but I'll send the solution on how to deal with this. It's just that the Jamboard is misbehaving. Okay, so before we go, because we're running with 4 minutes, except that part, which other part is an issue? Sandra, your mic is on. Yes, I'm saying except that part. I will send the solution on how to come up with the final answer there.
Yeah, like using the formula, the same formula that we used last year. Is it still okay, or now we have to advance to that one? It looks quite hard. At
Yes,
X not
huh?
initially,
Yes, you still find the same thing because X naught,
we can still use this one.
you can use this or that one, you still get the same answer. That's what I'm saying. You can use any.
So I mean, like now, or we have to advance to that one. If not, it changes. We used to use the X plus H there, where there is X not plus changes X.
Oh, I see. That one with H is M first year is the same thing with this one, no difference whatsoever. The application is that you are trying to measure this rate, this rate of change in Y because of a 1 unit change in X. Okay, so what they're saying is that change in X, actually this book explains it very well, because that change in X will be the initial value of Y plus the change in Y that was caused by a change in X. Because let's assume the initial Y was 20. Now that you've increased the income by, let's say, 1/4, okay, you're going to witness some change in Y, but the full change in consumption will be the initial amount of consumption before you change the income plus the change in income, because you have now changed the change in consumption plus the change in consumption that has been caused because of the change in income. So the total effect of that increase in income will be the initial value of consumption that you were consuming at plus the change in consumption due to that change in income, okay, which is being explained to be 6. Then that X naught is the X which is here. The initial value of X is this one plus the change in X. Are you seeing what I'm saying? Okay, then plus the same, you apply the same thing here. 2 plus the X naught is this X plus the change in X. Then you square everything. So whether you use this root or the root showed the alpha chan, you still arrive at the same answer. Okay, Sandra, are you there?
Yes, thank you.
Okay, good. Okay, so we looked at limits, so I'm not gonna look at limits because we looked at limits, we're together. If you didn't understand limits, go on YouTube, the video is there, check. Okay, so we are not going to look at limits. So if next time it will be me discussing this, because we can alternate anytime with Derek, you know. So if it's me, but before that, before I can say goodbye, someone's mic was on.
So, since you said limits, so it's first differentiate, then we find the limit.
Okay, there's a question. Do we first differentiate before we find the limit? So the limit of a particular function is we are saying that as I increase, let's say, I love practical examples. Let's say we're dealing with consumption and the income. Okay, let's say we are talking about consumption and income. What the limit is telling us is that, remember the definition of a limit is that the value that the function is approaching to, okay, as there is some change in some variable. Okay, so if we keep on approaching that particular value but it's not reaching it, what is the maximum that I can get? That is what the limit is telling us. So how do you do that? You just differentiate the function. Okay, so which notes should we use? Should we use these ones or actually I'm using a wrong book. The book I'm supposed to use is this one. Okay, but it's the same thing anyway. Okay, so the limit has changed in x approaching 0. So we are saying what is this function getting to as the change in x is becoming smaller and smaller and smaller. Okay, so what you do is it's just the same thing. You just find the dy dx of that particular function. So for example, in this case, what is the original function? I believe the original function was 6 plus 3, I think, something like that. It was 6 plus 3 because this is after we have introduced the change. So this will be 6x naught plus 3 times the change in x. So the limit is telling us that if the change in x is approaching 0, okay, if the change in x is approaching 0, the highest value of this function that I can get is 6 naught, which is just the differential calculus of this. Just differentiate this. Because initially I believe this function was 6x plus 3. So you're saying the limit of this function dy dx as the change in x is approaching 0 is just 6x naught, which is just the derivative. So yes, we just differentiate. Okay, that person who asked the question, yes, we differentiate. Okay, so let me give a trick. We use Alpha Chan to understand. We use this book that I'm using to apply. That's the difference. So if you want to understand, use this because this one has got notes and everything. But if you want to apply what you're teaching yourself, use this because here there are questions and everything. So I was saying, where are those questions again? Just a minute. I want to give you something like a take home thing. So let me just take a picture of this. I'll send it in the group. So each one of us must answer these questions, please, up to maybe question number, up to the last part except question 3. You only answer question 3 when I send what I'm talking about under this, the room, the quotient room. Okay, so the first question is just saying, given this function, find the derivative. So where they are saying the differential quotient, just I'm changing the question. Given this question, first you should just find the derivative. So you can start from B. Find the derivative of this function dy dx. So just differentiate this with respect to x. Then find f prime of 3 and f prime of 4. What they mean is, after you've differentiated this function, plug in these values and find the final answer. Then given the solution, given the function this, find the derivative of this function. Again, find the f prime of 2 and f prime of 3. But these are very simple. I'm looking for something a bit complicated because at UNZO you never find something simple. Actually, all these things that you are doing here, you never find them in any paper at UNZO. These are just there to help us have a proper foundation. Because I think I did mention in the beginning that we've done nothing. Okay. So for example, this question came not in our exam but in our test. This question, that's why I love this book. The tutor just copied everything here and gave us as the test. This whole question came. So we are going to look at this. Let me see, which question can you do? No, unless we look at maximization. Okay, so I will send this part. So please practice. Practice. Okay, if there are no questions, this is at 5, so we went overshot by 5 minutes. We can go.
Please send them to the group.
Oh, sorry. But I'll send, Kavini. I'll send in the group. I'm sending right now.
Alright, thank you.